Good evening. I'm Yvonne Stapp for Science for the Public, and I welcome you to tonight's Contemporary Science Issues and Innovations. Wind energy is one of the leading forms of alternative energy, and wind farms are being constructed around the world. Our guest tonight explains why offshore wind farms are increasingly popular and why the U.S. needs to catch up with the trend. Andrew Myers is an associate professor of civil and environmental engineering at Northeastern University, and he's a registered professional engineer in the state of California. His group at NEU is involved in the effort to advance offshore energy. Dr. Myers and his colleagues emphasize that coastal Massachusetts has the natural resources to be a global leader in offshore wind energy production. We'll hear about the benefits of this energy resource and the challenges of launching such wind farms in the U.S. It is a great pleasure to welcome Dr. Andrew Myers. Welcome, sir.
Thank you. Thank you for having me.
And we're delighted that you're able to talk about this because your group is working on some very advanced technology in this area. So first of all, I guess, could you give us a little background about wind energy in general, and then we'll go on to the technical.
Sure, yeah. So I guess one point I'd like to make is that onshore wind energy in the United States is one of the cheapest sources of energy in the whole country. In the Great Plains, the cost of energy is about 3 cents a kilowatt hour. It's one among the cheapest. In terms of efficiency, wind turbines are generating almost 60% of the power in the wind, converting that to electricity. That's the theoretical limit, and they're almost at that theoretical limit.
I see. So it would never be 100%, but it would be like 60% of that wind gets.
That's right, because the wind has to pass through the turbine, so you can't take all of the energy out of the wind.
Thank you.
Yeah.
Okay, all right. Then in terms of the design of these turbines, I understand it's pretty complicated, but could you give us some idea about that, the design of these things? That's your thing.
That's right, yeah, right. So one advantage to a wind turbine is to getting the hub, the center of the rotor, as high as possible. And so that's where winds are stronger and steadier.
Yes,
so you need a very tall tower to support a wind turbine. And then the mechanical equipment is all up top as well. So you need a structure that is tall to get the blades up high.
Yes.
And you need to support the generator and the gearbox and the mechanical equipment up at that height.
Okay. So, and this generates a huge amount of energy in the end, whatever.
That's right. Modern machines, we're looking at about a capacity, so that means the maximum power they can produce is about 10 megawatts. 10 megawatts.
A machine per
machine.
turbine.
That's right. 10 megawatts operating for a year can power something like 5,000 homes, and that's a single wind turbine.
And when you talk about a wind farm, then it's huge.
That's right. You're talking about hundreds of megawatts when you talk about a full wind farm. That's right.
Okay. Then in terms of offshore versus onshore, could we take that up and then go back to the engineering some more? Okay.
Sure. So, so offshore has some advantages. One of the main advantages is that the wind resource tends to be stronger and steadier when you don't have to go over rough terrain like you do onshore. So you get strong winds at low elevations offshore.
I see.
Another advantage of offshore is that there's developable space close to population centers, like all of the cities along the Atlantic coast. We don't have spaces onshore that we can develop massive wind farms. But offshore, very close to where the electricity is used, we can develop offshore wind farms.
That's a very interesting point because the world is urbanizing and you're going to have to serve these huge cities, presumably, you know, like all over the world. That is the trend.
That's right. And the kind of drawback to offshore compared to onshore is all else being equal, it's more difficult to build a machine offshore than it is to build one onshore.
Yes, and I can understand that. Do you have to worry about like what would you call it, the foundation, the soils in which you're planting these things? Can you give us an idea of that, and then?
Yeah, that's actually so. Europe has 3 decades of experience in developing the offshore wind energy industry, and so they figured out a lot of technical challenges. And the kind of soil geotechnical characteristics below at the seabed is a huge part of the technical challenge. And so we have different geotechnical soil characteristics here in the U.S. than they do in Europe. So we'll have to figure out some of those technical problems.
I see.
In particular, up here in the North Atlantic, we have boulders from the glacial moraine that has, so it's an issue that we'll have to figure out and how to construct these turbines in such a soil situation.
Okay, so that is an issue anywhere in the world, that's one of the things that they have to look at. What else do they have to consider in terms of areas for wind farms like that? So the soil as a foundation?
So soil is one thing. The shallower the water depth, typically the easier the construction. So a really great site has favorable soil characteristics, shallow water depth, and by that I mean like less than, let's say, 30 meters or
I
so.
see.
And an average wind speed of something like 8 to 9 or even higher meters per second.
Okay.
And if you have those three things, it's a very lucrative site for development.
Excellent. Now, in terms of the wind, you have said the East Coast is optimal for this in the world.
Yeah, the resource on the Atlantic coast of the U.S. is world-class. It has some of the highest average annual wind speeds in shallow water close to population demand centers.
I see.
And so it's as good as the best sites in Europe.
Okay. Are there some disadvantages to offshore in general and East Coast?
Disadvantages compared to onshore? Or?
Yes, well,
Yeah.
I'm not sure. I was thinking like hurricanes,
Yeah.
storms. The other one would be rising seas, and I don't know if that's an issue, but storms, would that be a consideration?
Oh, sure, yeah. So an offshore wind turbine will not be operating during a storm. It has the ability to stop its blades from rotating and to feather them, which means that it's trying to grab as little loading from the wind as possible during a storm.
Okay.
And so Europe, like I said, has 3 decades of experience
Right.
in designing these machines.
Yes.
And so they have a good understanding of how to design them for the storms that Europe gets, but Europe does not get hurricanes. So that is an issue specifically for the Atlantic coast that I've been working on, and that other engineers along in the U.S. are thinking about how can we design these to be reliable during hurricane events.
Could we go into that a little
Sure,
bit now?
yeah.
Because that's your area, I think, is the
Yep.
design. And so you're taking in a lot of considerations there. Could you give us a little view of what you're doing?
Yeah, so we're trying to calculate the reliability of an offshore wind turbine during a hurricane. So we want to know how often we think they're going to fail during a hurricane, and that should be a very, very small number, right? I mean, the people who are financing these farms, the people who are insuring these farms, want them to fail very irregularly.
Yes.
So we've been trying to put numbers on that, and we found that it is a pretty small number so far. And a lot of that is because when you are during a storm and you're telling the wind turbine to feather its blades, the loads will go down when the blades are feathered.
Yes.
So compared to when it's operating and trying to grab as much load as possible from the wind, it has a different way of orienting its blades that can reduce loads.
I see.
And then on top of that, and then you also have wave loading. So when hurricanes come, they're going to be pushing waves, and so you have to design the wind turbine to be able to handle the wind load and the wave load during a hurricane.
Yes.
But it's a practical problem. It's something we can design around.
Okay.
And like I said, our numbers so far suggest that the probabilities that these fail are very, very low.
That is interesting. I imagine this technology seems to develop very rapidly
Oh,
too,
sure,
in
yeah.
terms of its efficiency, a lot of other things. And so I want to talk to you about materials too. But at the end of the day, you're not terribly worried about the hurricanes or waves or whatever. You can address it.
I'm completely confident we can design around these issues. Yeah,
Okay.
they're practical problems.
Right. If you have storms lasting like several days and things like that, what is the storage capacity? How is that designed, batteries or whatever now?
Yeah, so during the storm, it wouldn't be generating, so there wouldn't be any kind of power production during the storm. Storage in general for renewable energy is a big part of the challenge as we're trying to push towards greater penetrations of renewable energy, is figuring out how to store the energy.
Yes.
And so that's a whole field of research.
Okay,
Yeah.
I ask it because we don't know in the general public that the storage capacity for these various types renewable energy
Yep.
they're improving.
And it becomes an increasingly important issue as the percentage of energy our country generates increases, as it generates more and more from renewable energy. So at first, as we're just starting to develop the offshore wind energy industry, it's not as big an issue as it will be when the industry starts to grow.
Yes, okay. All right. Can we go back to the design of the turbines and the materials, the size of these things, and the wind farms, the placement of the turbines? Could you tell us some of all of that?
Yeah, right. So construction practice, most of the offshore wind turbines in the world are supported by a structure that's called a monopile, which is just the simplest possible structure. It's a hollow tube that gets driven into the seabed, made out of steel. So the predominant support structure type is a monopile. There's another type that's called a jacket, which is it's kind of smaller triangulated elements that form a larger cross section.
A bit like a base. Yeah, I see.
A base, right? Exactly. Also made of steel. And then in all cases, and as you've seen, I'm sure, with onshore wind turbines, the support structure kind of above sea level, just like onshore above the ground, is also a hollow tube, a tapered hollow steel tube.
Yes.
So steel is the primary material for the support structures. Then the mechanical equipment is a variety of materials up in the nacelle at the top of the wind turbine, and then the blades are made out of fiberglass.
Oh, okay, all right. Now those blades are enormous.
Enormous,
and is the offshore, are they larger than the ones that are onshore?
Yeah.
Do you know what I mean?
So the way technology is being pushed is towards turbines with larger power capacities. You get to a larger power capacity by having a larger rotor, by having a larger circle that you are kind of grabbing wind energy from. You get a larger circle with a longer blade. So the very most modern offshore wind turbines now are looking at blades at like 100 meters long. I mean, they're just enormously long structures.
Okay, so that's one thing. One more thing with the material, and then I'd like to talk about that placement, the wind farm design. That I think I asked you at one point that I've seen some reference to rare metals. Is that a factor that is of interest to you or a concern?
Yeah. So the generator that is converting the mechanical energy of this spinning rotor into electricity relies on magnets, and permanent magnets use rare earth metals, and so there's environmental issues with how those are harvested.
Okay.
And so folks are trying to come up with generators that use less rare earth metals.
Okay. Is there a possibility there will be an alternative, some synthetic or something like that down the line to replace that? No?
Yeah.
It has to be the rare earth because they're limited too, I think.
I'm not totally sure about that.
Okay. Yeah. Okay. And then the structure of these enormous wind farms, the placement of the turbines. Right. Could you tell us, is there a design factor there?
Oh, sure. So one wind turbine is grabbing energy from the wind, and then that energy is not in the wind, behind the wind turbine, because the wind turbine has taken that energy.
Yeah.
So you can't just have two wind turbines right next to each other, because the one behind the first one will not be seeing as much wind energy, because this first one has extracted the energy already. So the way so you have to space them at a distance that's far enough away that the next turbine down the line can still grab the full wind energy. And usually that's something like a kilometer or two. So these are spaced about a kilometer or two.
Wow, yes, yeah. Then how many turbines are typically in the wind farm?
Yeah, so the development, the kind of furthest along development off the coast of Massachusetts is looking at an 800 megawatt development. And so if they use 10 megawatt turbines, that would be 80 10 megawatt turbines.
Okay, and for megawatts and gigawatts, could you refresh our memories?
Yeah, so if a wind turbine is operating a capacity factor of about 50%, which is a high capacity factor, a 10 megawatt a turbine with a 10 megawatt power capacity in a year can generate enough energy to power about 5,000 homes.
Okay, all right. So that's
one
that's
turbine.
One.
That's one
I
turbine.
just wanted to make sure that we had that very clear, because you made reference to that a little bit before. In terms of the design, I think this must be very exciting. This time, your engineering, I think it sounds as though you'd have to put together not just civil engineering, but a whole pile of things. Is that true?
Oh, it's certainly, yes. So, I mean, at the least, you need structural engineers, mechanical engineers, electrical engineers, construction managers, marine warranty surveyors, insurers, financiers.
Yeah, right,
I mean,
right,
it's
right,
a
right.
complex.
But even in terms of the engineering, it's like a huge brain there. One specialty is not adequate for designing it, apparently.
That's right. That's right. A whole host of engineering types are involved in designing a wind turbine.
Okay. If the research end of this is becoming international, your group has done some international work with international teams. And so is that coming?
That's right. Well, I mean, so Europe is so far in front right now that we are very eager to learn as much as we can from the Danes, from the Germans, from the French, from the British.
Norwegians, everybody else has been
Swedes.
at this.
That's right.
While you're on there, why are they so far ahead?
Yeah.
Some of these people have oil, for example, you know, and they were selling oil, and they've gone off to do the wind
That's right.
and commit to this resource. Why are they so far ahead?
It's interesting that you mentioned that. Yeah. So two of the largest offshore wind energy developers are companies that were oil companies. So
Yeah.
Ørsted is a Danish company that was an oil company, and Equinor
I
as
don't
well.
know the name. Yeah, is
That's
that
right.
Norwegian or
Equinor is Norwegian, and
Okay.
Ørsted is Danish.
Yeah.
And so, yeah, that's a tough question. I'm not exactly sure. I mean, they have the force of public opinion, and so I think the public is behind it in Europe. I think also European countries have federal energy policies, where in the
Yes.
United States it's the states that are
Yeah,
controlling
right.
their energy to a large degree.
Yes.
And so I think that having a coordinated federal energy policy
Yeah.
can help to kind of push these industries forward.
Right, but also that commitment, that solid commitment by the governments in themselves. And do you have any idea why? It seems as though there is almost a resistance to renewable energy. We're always catching some kind of an argument why this is just virtually impossible. Let's bring back coal, which is a fantasy, and so on. Why this resistance in the United States, and why it's successful, apparently?
Yeah, that's a complicated question. I'm not
Okay, it's not an
entirely sure.
engineering
Yeah,
question,
yeah.
just frustrating.
Right.
But it was in the very good article in Phys.org that I read about your group mentioned this, that it is frustrating to engineers, people in this field, that the United States keeps resisting, basically. So do you have any ideas how we might promote it better?
Well, I think one thing is making sure that folks realize how tremendous the resource is off of the coast, specifically off of the Atlantic coast. So,
Yes.
so the Atlantic coast has enough developable offshore wind energy power to power the entire country.
This is
It takes
incredible.
about 1,000 gigawatts to power the whole country, and there is that amount
That
of resource
capacity is there.
is on the Atlantic
Which
coast.
raises the question again, why hasn't this happened? You know, it's almost a pilot thing off Rhode Island, but nothing has happened. What are our prospects in the future in terms of what you know about the development?
Oh, I'm very bullish about the industry.
Yes.
So in particular, there are something like 20 projects in the works for the United States right now.
Okay.
Several in Massachusetts. So the one I mentioned
Yes.
is an 800 megawatt project that was that recently just was awarded offered a long-term contract to the state of
Okay.
Massachusetts at a very low price. There are, I don't know if you saw a few months ago, but there were 3 lease areas off the coast of Massachusetts that went for $130 million each, which is a stunning amount of money for an offshore wind energy lease. So the industry, and it was major international players that are leasing these areas. So the industry all over the world sees the Atlantic coast and is looking to help us get this industry going. It looks like it's going to be a big deal really soon.
Oh, that's excellent. Well, I can understand that, like states like Massachusetts, I don't know about Maine, Massachusetts, definitely, New York.
Yep.
If those states get it started, first, how long would be before it's deployed, that it's productive?
Well, this first project I keep mentioning, the one that the state of Massachusetts now has a long-term power contract to buy power from this developer, I mean, this one is imminent. I mean, it's
this is great.
Yeah, I mean, they're talking about construction within years.
That's excellent, and just in time.
Yeah.
How long does it take to put up a wind farm like this that you're considering, this project?
Yeah, and so that's hard too, because we have the European experience, which has decades of developing the supply chain, the workforce,
Yes.
and all these things. So having the first one in the United States, it's kind of, we have to figure it out.
Right.
Yeah,
Okay.
so it'll be years for sure.
Right. Is it possible for the United States to produce the components here? I understand the turbines might be produced in country X. Can we do all of it here?
Yeah, I mean, the entire machine involves an international supply chain.
Oh, it is?
Yeah, there are so the ones in Rhode Island, those turbines came from France.
Yes, I see. And France had parts from Japan or what?
Oh yeah, and then if
that's
you go
just it.
after manufacturing, sure, yeah.
Right. So it is international in principle,
It is.
this kind of thing, and you're not going to get around it. You can't bring it all home or anything.
But the support structures, a lot of the material goes in the support structure, and the support structure can be made domestically. So here I'm talking about, I mentioned the monopile
Yeah,
or
right,
the jacket
right.
and the
And the
tower.
steel tower and stuff.
So those, and the U.S. has a lot of experience in offshore construction in the Gulf of Mexico for oil and gas structures, and so we
Right.
have a lot of experience on similar offshore structures.
Okay, all right. So it is all doable, and there are things in the works, and that we really have the capacity potentially to supply the whole country.
Yeah, it's stunning how large the resource is in offshore
And
wind.
this is all, you would produce it in off the East Coast?
Yeah, I mean, so I don't think that's the optimal way to get all
right,
of
I
it,
understand.
but
So what
but
about
it's-
the West Coast?
Right, exactly. So I mean,
Right.
and there's other
Other
great energy
energies,
sources
right,
as well.
right,
But
right.
just to let folks know that how big the overall resource is, that if it were developed, it could power the whole country.
Yes,
but that isn't
right.
the optimal
You're,
way.
I understand
Right.
that in principle it
Right,
could.
exactly.
Just why, out of curiosity, the West Coast? It's not big a consideration.
Yeah, so the West Coast tends to have deeper water than the Atlantic Coast.
Yes,
that's the big,
right off,
right. So the
And
West
we're
Coast
sloping.
is exactly right, and so the West Coast is thinking more so about floating wind turbines.
Yes, I meant to ask.
So these are wind turbines which are not supported by the ground;
Right.
they're supported by floting.
Yes.
Structures.
Could you tell us a little more about it? So you're not thinking of that for the East Coast, but for the West Coast, wherever you have like a sharp drop off the coast and the water becomes deep too quickly, then the floating is a possibility.
Well, I think floating. So I am thinking about floating. Most folks on the East Coast are thinking about fixed bottom.
Right, I
at the
understand
moment.
that, right.
But even still, the East Coast has a lot of resource that is inaccessible by fixed bottom
I
structures.
see,
So
I
so
see.
even on the East Coast, I see eventually the opportunity for floating structures. It's probably more immediate on the West Coast, just because they don't have large developable areas for fixed bottom structures.
Right, okay. So this is really very, very interesting. Gets better by the minute
Yeah.
here. Now, another thing is that when the onshore wind farms, one of the objections, and it came up right here in Massachusetts, was not in my backyard. And there was all this noise or all these other concerns.
Yep.
That is not a concern at all with offshore, is that correct?
The sites that I've been mentioning are tens of miles offshore, and so the influence on kind of view sheds is minimal. Compared to onshore, the effect on kind of views, I think, is much
Okay,
less.
so we can eliminate that as an objection. And then another one that crops up, but it came up, of course, with the onshore, I think more, was, pardon me, the environmental, like birds and that sort of thing. Would that be, is it, in the European experience, for instance, is it really a factor?
Yeah, the birds are a factor, and the factor that I see brought up more often is whale migration during construction. So construction is
right.
noisy.
Yes.
And when you're pile
right.
driving a monopile
Right,
and hammering
right.
it, it's loud and can disrupt whale migration. So Europe has developed technologies for minimizing the noise.
Right.
They have an understanding of the periods of time when it's okay
I
to
was
make
going to
noise.
say, right, when the whales are not migrating, you'd use that period for construction.
Yeah.
And then after that, it's not such a big deal, right? Once the wind turbines are moving around, then that's not affecting anything in the water.
Right.
Essentially.
Some folks are hopeful that it can be a better habitat for some fisheries. So the whale issue, though, is mostly an issue during construction.
Right,
Yeah.
I understand that, but that's something that you can resolve. It's a problem that can be resolved. So it sounds as though you're good to go in here, and you are in the middle of this at just exactly the right moment. You must be a happy man.
Oh, it's so exciting to be part of an industry that I think is about to take off,
Yes.
and that I think is going to be a really important part of our kind of energy landscape in the United States.
Right,
Yeah.
right. Do you ever compare it with, say, solar? I understand people get into the engineering, the design engineering of these particular things, and then they don't, pay much attention to the other. Did you ever consider that also, or just?
Yeah, well, so I think solar is a part of the solution, most definitely.
Okay.
Yeah.
All right.
Solar works well in a distributed sense. People have solar panels on their rooftops. They don't have
Right.
wind turbines on
Exactly,
their rooftops. Wind turbines
exactly.
work best in kind of commercial scale.
Yes.
But solar has the benefit of it can be distributed
Right,
nicely.
or in very dry areas, so they joke about turning the Sahara into a solar farm,
Yeah.
at this point.
And I think solar also has the benefit of it tends to be complementary with wind energy
Yeah,
generation,
okay.
where when solar is generating the most, wind tends to generate less, and at night when solar is generating
Right.
the least, wind tends to generate a lot.
That's
so
an
they
interesting
kind of work well
point.
together.
Yes. So these things are complementary. These
are.
new forms of energy are complementary. How optimistic are you about the United States, the situation for us now? Do you see us moving forward despite resistance in some quarters?
Yeah, so like most of my thinking is on the offshore wind energy industry in particular,
Yes.
and ever since we had that Rhode Island project,
Yes.
that demonstration project, we had offshore wind turbines, industrial scale in the United States. Every year the conferences that I go to about offshore wind energy,
Right.
there are more and more people coming. There's more and more energy. The major international developers are moving. They're
Okay.
creating offices in the Atlantic coast. They are leasing the areas.
Right.
And
So
they're-
you have investors are interested, nations are interested, and even in the United States, you have at least investors that will commit and so on. Do you see any shift from, say, fossil fuel? I've often wondered, why don't they just move over into these kinds of things, because they have dealt with huge equipment, huge projects and things. Why keep digging up oil? Do you see any of that happening? They're making a shift to commit to renewable?
Right, so I mentioned the two in Europe. So
Yes,
Equinor,
y-
it
yes,
used to be
right,
Statoil,
right, like here.
and then the Danish one, Shell as well. So
Shell is
Shell
good,
actually owns one of the leases off the coast of Massachusetts.
Okay.
So yeah, the oil companies are.
If they see that as profitable, you think they might make a shift. I ask that because there's this renewed effort to drill in the oceans and so on, and a lot of people are very upset about it. And those are the companies that we've had problems with before. Is there anything else in terms of like the energy security or the engineering that we should discuss here that you would like to bring up?
I think so. Maybe if I could talk a little more about floating.
Yes.
Yeah.
Oh,
okay.
yes.
Yeah, sure.
Okay.
Yeah. So when I was citing those numbers of the potential for the Atlantic coast to generate offshore wind energy that powers the entire country, I was including areas that have water depths that are too large to have a fixed bottom offshore wind turbine. And so I think there's an amazing opportunity for engineering creativity, for engineering ideas to support, to create floating structures that can support offshore wind turbines. There's some advantages to floating. I mean, you can construct them at port, where it's easier to construct things than it is at sea.
I
You can
see.
you can go to the very. You're not kind of constrained in a single location. You can go to the best wind resources.
That's very
It
interesting.
unlocks a huge amount of locations along the globe for harvesting offshore wind energy industry.
Is it potentially could you see this heading toward floating farms in the end, floating wind farms, to replace what would you call it, the stable one, fixed bottom?
Right. So if you look, the National Renewable Energy Lab, that's the U.S. National lab that does a lot of work on the offshore wind energy industry. Their projection is that eventually floating wind energy could be cheaper than fixed bottom. So they are thinking there are some advantages to floating, but there's a lot of technology, there's a lot of engineering. For anyone who's kind of looking for an engineering challenge that they want to think about, I think developing floating offshore wind energy technology is a good one.
That's very interesting. And while we're on that, you're in this fabulous field that seems like, and you point out, I mean, it requires the technical skills, but also just being creative, just being able to see design down the line. Do you have any advice for young people that might be considering it, because they say that the renewable energy is just huge for jobs, for all kinds of things, certainly?
Yeah, right. Well, I guess one point I just hope that that young people might take away from this is just how large the resource is, how significant the industry already is and is likely to become.
Yeah, it sounds like.
And just the huge diversity of jobs that are going to be required by this industry. There's engineers, there's going to be folks constructing them, there's going to be folks maintaining them.
Yes,
it's a lot of really good, really important jobs, and so I see it as a really meaningful potential career path for young people. So I hope they consider it.
Right. It's inspiring. I think it would be really exciting to be working in this. And one more last point is that is there something that we could do as just citizens to get the governments to pay more attention?
So kind of one encouraging thing that I've realized from the past many years thinking about the offshore wind energy industry is that it is more locally driven than you might think. I mean, it is really states that are driving this forward. And all of this kind of significance of the industry, it became really significant when Massachusetts passed a law requiring that a certain amount of power be generated from offshore wind energy. And as soon as the law was in place, that changed everything. Folks were willing to move offices to the Atlantic coast. They were willing to start investing resources. And so
you
local,
can do it local.
And it's local too. Yeah.
Yes.
So kind of local.
I mean local, statewide.
Statewide laws are driving this industry. So
very interesting. So, and then if enough of those states get on board with something like that, it will simply perpetuate. Other people will be forced to get on the ball here.
Yeah.
Well, Dr. Myers, this was very interesting to talk to you about this, and I wish you the best of luck. I think you're going to have a wonderful career, and the project at Northeastern University sounds very interesting as well.
Yeah, thank you so much for having me. I enjoyed our conversation.
Thank you.